Hello, my name is Jonghyun Hwang, a mechanical engineering senior at University of Illinois at Urbana Champaign. Today, I'll be presenting about 3D printing of biomimetic pneumatic actuators by direct ink writing of the ultraviolet-light curable elastomer inks. The field of soft robotics is getting an ever-increasing attention. However, methods we take to fabricate a soft actuator involve manual handling, 3D printing of molds, casting, and post-processing. This is highly time-consuming and is also limited in attainable internal geometry of the actuator. So, in this study, we developed a direct ink writing DIW soft material 3D printer that enables construction of complex geometries unobtainable by manual fabrication. The goal of this study is to 3D print a fully functioning soft pneumatic actuator. This research project is divided largely into three sections. The first is for curable elastomer ink development. The second is a printer, hardware, and software development, which is turning a fused deposition modeling 3D printer into a direct ink writing 3D printer. And lastly, actual printing of pneumatic actuator and implement a bio-inspired idea onto the actuator composite to verify 3D printed soft actuators performance. Now let's look into how the elastomer inks were developed. The total of 3 different inks, soft ink, stiff ink, and the support ink were developed. The soft ink is highly elastic and inflatable. On contrary, the stiff ink is used as a strain limiting component, constraining and guiding the direction at which the soft actuator will deform. Lastly, the support ink, made from water-soluble material, supports the overhangs and let us achieve complex geometries unobtainable by casting fabrication. We base our elastomer ink formula on the formula developed at ETH Zurich, but used a different type of photoinitiator and rheological modifier. We used URGA-Cure 819, which absorbs 365 nanometer light to cross-link the elastomer strands in the inks. To rheologically tune the elastomer inks to be suitable for 3D printing, we first identified the performance requirement and found the suitable chemical. The inks should be able to flow easily when the pump is pressurized. In other words, the ink should have a lower viscosity when the shear force is applied, and should retain its shape when they sit on the building platform and not flowing out. Therefore, we had to achieve the shear thinning effect in the inks we developed. Such characteristic was attainable by adding a shear thinning agent called Thivex, and the ink's rheological performance were measured using rheometer. The results are shown in the figure 2. The graph on the left was a control ink, and the one on the right was the ink with Thivex added. As you can see, as the shear rate increases, which is in the x-axis, the viscosity, the blue data points, decreased for Thivex ink. On contrary, the control ink had an almost constant viscosity throughout the entire span of shear rate. Next, the DIW 3D printer development took place. We purchased a commercially available 3D FDM printer and took out unnecessary components and replaced with custom developed components, such as 3D printing tool head. The tool head contained ink-loaded syringes, which connects to air pressure regulator and external air compressor. The control of the 3D printer was done through custom developed G-codes. Lastly, the end goal of our project is to print a fully functioning pneumatic actuator. However, since we are upgrading our printer hardware and firmware right now, this portion of the project has been postponed. The actuator that will be printed is designed as a bending pneumatic actuator. The design and the bend shape of the actuator was inspired from Harbor Steel's Hind Flipper. And this structure is extremely hard to be made out of traditional casting manual fabrication method. We expect that this actuator will be used as a highly efficient underwater propulsion mechanism for robots. Our future plan includes mechanical testing of cure specimens and attaining a better printing resolution by modifying rheological characteristics of the inks further. Thank you for listening, and please direct any question to me.